Sections on 2.1, finding limits algebraically. The other form that we did was graphically, and this time we're going to go ahead and do algebraically. So algebraically is pretty much what it sounds like. You're going to go ahead and do the algebra. So for example 1, when we have the limit as x approaches to -1, we're going to substitute that into this equation just like algebra. So let's go ahead and do that. I'm going to go ahead and put -1 squared, and I like to put the parentheses, especially if you have a negative, so make sure you do that. Be careful of that. We have 2 times -1 and then plus 3. So if we simplify this, -1 squared will give us +1. 2 times -1 is -2, and then plus 3. So if we simplify that further, this is 4 basically, right? 4 minus 2 will give us 2. So the final answer is going to be 2 in this case. So it's just algebra, just substituting x equals, or basically x equals -1 into this. But we're saying that graphically, if we go ahead and graph this out, when x is approaching to -1, the y number is 2, because we have seen this graphically yesterday. So now we're going to go ahead and do algebraically. Okay? Now example 2, we're doing the same thing. The limit as x approaches to 2 of x squared plus x minus 4. So if we're saying that we're going to graph this out, we're trying to figure out is what is the left side and the right side number that's going to approach when x is equal to 2, which we saw yesterday in picture-wise. So this time it's going to be algebraically. So now this one right here, I can actually just substitute it into this equation and then figure this out. So let's go ahead and do that again. So 2 squared plus 2 minus 4. So 2 squared is 4 plus 2, and then minus 4. The 4's will probably cancel each other out right there, right? And we're left with is basically 2 again right there. Okay? So that's what algebraically is. Because yesterday we did the graphic method, so we graphed it out and we found out the left side and the right side of each of these values right there, right? If it existed. And remember, on the left side and the right side, if it did not exist, because one went up to positive infinity, the other went down to negative infinity, etc. Okay? Now, what we're going to also do is something like this with that rational function. So this is the tricky part, is the rational function. In rational equations, sometimes it does not work. So for example, in this case, if I substituted in this 2 into here, you can see that the 2's will actually cancel each other out on the denominator. So because the 2's cancel out, this is going to be undefined. So we know in this case, it's one of those pictures that we just had yesterday, where either the graph has an open circle, and it either goes up to positive infinity or negative infinity, or it's just an open circle in general right there. Okay? So for the classwork that I want you to do on these kind of problems, when it is a rational function, because I can see right away that this is going to be an asymptote, I'm going to go ahead and ask you to graph it out. So let's look at the graph for this. So if I go under the graph, and I have this equation already in there, so let's look at it again. The 2x plus 4 right there. Right, 2x plus 4 in there. So I'm going to just go ahead and turn off the other equation right there. So we turn it off, and let's graph this out. We're going to get a graph something similar to this right here. Okay, and let me just go ahead and zoom. So I'm going to go zoom 0. That's going to zoom fit it, and that's going to give us a better graph right there, or at least a starting point right there. So I don't like this graph. I'm going to go ahead and adjust the window size. So let's see, -5, 5 possibly. 700 and something sounds too big. So let's go -20 and 20. Let's play with that graph right there. Alright, so that's a little bit better. Okay, so as we said right here, this is going to be as x is approaching the 2. So that's all we care about. We don't actually care about any part of this picture right here. We don't care about any parts of the picture unless we're talking about 2. So at 2 right here, can you see that this right here is 1 and this is 2 right there? We obviously have is a vertical asymptote. That's not surprised, because right here we said that x minus 2 is going to be a vertical asymptote. So at 2, we're trying to figure out from the left-hand side and also from the right-hand side what this equation is. Because if you remember yesterday's homework, we did the right hand and the left side if there is no plus or minus after that 2 right there. Okay? So from yesterday's, we learned that 2 from the right-hand side, because this is the right-hand side of that vertical 2 right there, it's approaching to positive infinity. And as we go from the left-hand side, we're approaching to negative infinity. So obviously at 2 right here, the limit as x approaches to 2 of this equation, it does not exist because the left side and also the right side does not match. Okay? Let's go ahead and try the next one. So the next one right there is the limit as x approaches to 2 from x minus 2 all over x squared minus 4. So let's go ahead again, graph that out. So I have that equation already graphed to save us time. But I'm going to turn off this graph and turn on the other graph. So let's see what that looks like. Okay, so something like that. And again, we're looking at 2 right there. So I don't need much of this picture right here. So I'm going to just go ahead and adjust the window size. Oh, let's see, from -2 to 5 sounds good. Maybe like -10 to 10, because I think the other picture was a little too small. Okay, so something like that. Maybe even smaller than that. Let's see, let's go 3. 3, maybe 4. 4 is a better number. So 4, -5, and +5. Okay, so let's play with that. Okay, so we get a better picture in there. Okay, so again, we're looking for the limit as x approaches to 2 of this equation right here. So 2, this is 1 about there, and this is 2 right there, okay? But if I substitute this 2 into this equation right here, we can see that 2 squared is 4, 4 minus 4 is 0. So again, this is undefined right there, which is again, is no surprise, but if we look at this undefined, we actually have a problem. Because normally on this, like this other problem right here, on example 3, we actually saw the vertical asymptote. But in this case, we actually don't see a vertical asymptote. So that means at 2 right here, there's probably a hole right there. And how do I determine that? Well, you go to the table, right? So let's go to the table. Sure enough, at +2 right there, we have an error. And also at -2, we have an error. So that means I'm not sure what that graph is because I really don't care. I'm going to look at this right now only. So at +2, there's an error. So an error tells me on the calculator that when I graph that out, it's either going to be a vertical asymptote or an open circle. So obviously, I don't see a vertical asymptote right here. So that's going to be an open circle right there. Okay? But if you actually look at it carefully, the left side and the right side obviously is going to approach to a y number because this is an open circle like yesterday's homework. Okay, so that means we probably have to trace it, and let's just trace it at 2 right there, and obviously it's going to show nothing right there because that's an error. Okay, so if I find the limit as x approaches to 2 from the right hand side, I'm going to just call all of this f of x just so saving myself time so I don't have to rewrite that whole equation right there. Okay, so 2 from the right hand side, I'm literally going to go ahead and take this button right there and move it to the right hand side once right there. Can you see that? So then this right here, the y number again is all we're looking for. So the y number comes out to be about 0.2447. So I'm going to just go ahead and write, or 448. Let's go with 8. Okay, so I'm going to just go ahead and write that just to see what that looks like. And then we'll do it from the other side so you can see and compare it. So let's do now the limit as x approaches to 2 from the left-hand side of this equation now. So go back to that 2 right there. Go back to 2, enter, and again, that's the open circle that we're talking about at 2, okay? So now we're looking from the left-hand side. So literally, just take that arrow key right there again. From the left-hand side, just move it over one more on the left-hand side right there. So on the left-hand side, that's going to give us about 0.253-ish, somewhere around there. Can we see that? So this right there is going to be approximately the same as this right here. So just to eyeball it, because obviously it's an open circle, we're just going to say then the limit as x approaches to 2 of f of x right there, we're going to just take about the closest number that we can figure out between those two numbers right there. So it's about 0.25 is probably the closest, because this is 2.5 right there, and if I round off this right here up to the third right there, that's going to round up to 5. So I think the best number we can say is 0.25. Okay, so that's what we're going to do with today's homework. Is if you don't have a rational fraction, right, or rational equation, which is a fraction, then you can probably substitute the numbers in and get a number out right here. But if you have a rational equation like we just did right now, these kind of problems, you're going to have to substitute it in to see if the denominator equals to 0. We don't want the denominator equal to 0 because then that's undefined. So that means we're going to have to graph this out, figure out if there's a left side and right side, because remember this one right there, that was a D&E, does not exist because this right-hand side went up to positive infinity, the left-hand side went to negative infinity, so the limit does not exist. And in this case, this was an open circle, so we had to do the right-hand side and the left-hand side, and then determine at that place at 2 what that final answer was going to be. Okay, so go ahead now and try the homework assignment.